This is Brian Putt. I'm chair of the energy practice at Probability Management. Today we're going to talk about the application of data tables in Excel. Data tables change a single variable and calculate the workbook and stores the selected results. The stored results normally depend on a variable changed by the data table. For discussions in this video, let's assume that this variable is always called PM_index. Some applications include doing sensitivity analysis, deterministically running multiple scenarios and then storing the results. Or we could use the data table to conduct a Monte Carlo simulation. And this is what SIPMath does. Data tables come in two varieties. They come in a one or a two variable data tables. Today we're only going to be talking about the one variable data table that can be used for sensitivity analysis and also for simulation. And the one variable data table is what SIPMath uses. The data tables can also be either column or row oriented. This is a very confusing concept, so let me demonstrate it with some pictures. First of all, we said we had this PM index. So let's assume we've defined a variable called PM index, and that's where that variable is going to go. In the row-oriented data table, the values that are going to go into PM index are along a row. So 1, 2, 3, 4, 5. This could be much longer, but let's assume it's only 5 long. And let's assume that I want to calculate the sensitivity of the MPV to various interest rates. So I could calculate my MPV and put that value right here as a formula and put the interest rate that I'm using down here. When this is set up as a data table, all the different MPVs and the interest rates will fill in these 5 scenarios. When setting up a row-oriented data table, we are going to fill in this entry here with this cell reference. The row input cell does not relate to this section here. You'll see this will be more transparent when we go through the example. In the column-oriented data table, the data table's flipped. So over here we have the values that PM index is going to take on, and then over here we have the different variables that we want to capture for each one of these values of PM index. And in the column-oriented data table, this cell here, this column input cell, will reference PM index, and the row index will be blank. So here is an Excel file that I've started, and it's starting with the template that I showed you in the PowerPoint with a row-oriented data table, but it's not been filled in yet, and that's what we're going to show you in this Excel file. Here's the MPV reference and the interest reference. So let's build our deterministic model. First of all, we need a cash flow. So let's put some cash flow here, and let's assume that it's minus 10, 3, 2, 7, and 4. And then we'll calculate our MPV over here. And we're going to need a discount rate, aren't we? So let's put the discount rate here. I guess it's interest rate we're calling it. We'll call that, let's start off at 10%, okay? 10%. So the MPV is equal to, I need the discount rate there, and then I need the values. So the value of this cash flow discounted at 10% is 2.16. And if I was to change this to, let's say, 5%, it's now 3.82. So let's assume that I wanted to get a sensitivity table of my cash flow at various discount rates. So how might we do this? First of all, what discount rates do we want to use? I'm going to put those up here. So this is going to be interest rates. And we'll start off here. Let's put in 0. We'll put in 0.25, 0%, 2.5%, 5%, 7.5%, and 10%. Those are our 5 scenarios. We could have extended this out if we wanted to, but let's just use 5. And now my MPV is equal to this value that I calculated in my model, and the discount rate that's associated with that MPV is equal to this. Now what I want to do is I need to set up my PM index. Where's my PM index? Oh, I don't have my PM index. What's this one up here? Let's call that the PM index. PM, I'm going to put the range name here. And then there's all kinds of ways to generating a range name. I'll just type it in up here for simplicity. PM underscore index. And now we can see this has a range name of PM index. So what I want to do is if I had this interest rate change based on this PM index, I'm going to make that yellow because that's an input. Then anytime PM index changed, the interest rate would change and this MPV would change. So what I'm going to do here is I'm going to say this is equal to an index of these values, comma, PM index. Right? So now, at PM index of 1, it picks up the 0, it calculates an MPV of 6, which is just the sum of these numbers down here. And if I change PM index to 5, my interest rate goes to 10%, and now I've calculated an MPV of this cash flow based on 10%. So let's set up the data table now. The data table is going to be defined by this solid line here, and what I like to do is I like to set these up as gray cells, so I know these are special row and column for the data table, and my results are going to be in here. So I'm going to highlight this whole area and go to Data, What If Analysis, Data Table. This is a row-oriented data table, so I'm going to put the row input cell is going to refer to PM index. And I'm going to say OK. And when I do that, this whole table is going to get filled in. And there are the results we want. Let's format this a little bit. So at a discount rate of 0, my MPV is 6. At a discount rate of 10, it's 2.16. And I can come in here and manually change this. Let's put in a 3 as a different number. So when I put a 3 here, my interest rate's now 5 and my MPV is 3.82. And if I came over here to the 3, you can see I have values of 3.82 and the 5%. Let's format this as percentage. So that's how we can do a row-oriented data table. Let's stop there, and in our next video we will discuss how SIPMath uses a one variable data table but uses a column-oriented data table rather than the row-oriented data table that we've just described. Thanks.